In this video, we're going to talk about volume of pyramids, kind of where the formula comes from, and then how to calculate volume for pyramids. So let's talk about where the formula comes from. I at least want to give you some idea of where it comes from. So if you recall, for area, if you think about a parallelogram, and we cut that in half, we have a triangle. And for a triangle, the area formula was 1/2 base times height, half of that of the parallelogram. If we look at volume for this pyramid, and typically when we think about a pyramid, we think of a square pyramid. It doesn't always have to be a square pyramid, meaning that the bottom is a square. We could have a rectangular pyramid, we could have a triangular pyramid, we could have a pentagonal pyramid. It all depends on what that base shape is. And again, the term base is used. It's whatever the non-triangular side of your pyramid is. And then there is the case where it's a triangular pyramid where, I guess, pick a triangle for your base. So if we think about the formula, where it comes from, it turns out that, say we had a prism that had the same height and the same base shape. So if I was to extend all these up at right angles and make essentially a case around it. Now we know that to find the volume of this blue shape, or this blue figure, it would be the area of the base times the height. Well, it turns out that similarly to the area of a triangle, a pyramid, instead of it being a half, it is 1/3 of the volume of this theoretical prism around the pyramid. So all we have to do is find the area of the base, the height, and then either multiply that by 1/3 or divide it by 3. Either one is fine. So ultimately, our formula is going to be volume is going to equal 1/3 area of the base times the height. Or you could think of it this way: you could take the area of the base times the height divided by 3. Whichever one you prefer is fine. They both mathematically are equivalent. So ultimately, this is the takeaway from this chunk of the video. Just what the formula is, and I wanted to give you an idea of where it comes from. So let's dive right into an example. Now, when you're actually doing this in practice, you're not going to sit there and draw the prism that would encase the pyramid. So let's look at a stereotypical pyramid where we have a rectangular base. So this one's not a perfect square because we have one side that's 4 and one side that's 3. So the first thing I need to do is I need to figure out the area of the base, which I'll do in blue. So we're just looking at the very bottom panel here. So that area is a rectangle. So we can say, all right, that's 4 times 3, which is 12. So that's the area of the base. Now I have to look at the height, which in this case, this pyramid is 5 units tall. So the volume is going to equal 1/3 times 12 times 5. Area of our base goes right here, and the height goes right there, and then the 1/3 is just the 1/3. So I'm going to take 1/3 of 12, so volume is going to equal 4 times 5, which means the volume is 20. And again, we're talking volume, so we're looking at cubic units, or units cubed. Either one is fine. You just go straight to the formula, and then simplify the expression as much as you can. Now let's look at one that's a little less stereotypical. Let's look at a triangular pyramid. I want to show you that this does indeed work, and it's the same kind of idea. So again, what I have, and it's a little bit difficult to see, this blue measurement is the base triangle, the bottom triangle. So I'm giving you the height of that bottom triangle, and it's 5. So the area of this triangle, the very bottom triangle, if you kind of ignore the pyramid for a second, is going to equal 1/2 times 5 times 3, which, so half of 15, that would be 7.5. That's the area of the base. And then we're going to calculate volume. It's 1/3 times the area of the base, which we know to be 7.5, times 10. So the volume is going to equal 75 over 3, because 10 times 7.5 would be 75, and then I'm going to divide by 3, which would mean that my volume is equal to 25 units cubed. Now it turns out that, yeah, no matter what shape you have on the bottom, you can still use this formula. You just have to find the area of whatever that bottom face is, and then multiply that by the height, and then either divide it by 3 or take 1/3 of it. Either one is fine.